Imagine a world where AI doesn't need billions of parameters or massive GPUs to be powerful. Now, imagine that this world is already here. Microsoft just released something that could shake the very foundation of how we think about AI scale and capability. A 14 billion parameter model, beating GPT-4 level reasoning tasks, and it runs locally. Yes, on your laptop, maybe even your smartphone. Let me walk you through why this changes everything, not just for AI researchers, but for all of us. Hi, I'm Francis, and today we're diving into the fascinating world of Phi-4 reasoning models, Microsoft's latest surprise drop in the race for intelligent, efficient AI. In a world obsessed with bigger and bigger language models, GPT-4, Gemini 1.5, Claude Opus, DeepSeek 67b, Microsoft has taken a bold turn in the opposite direction. They've asked, what if smaller can actually be smarter? The result? The Phi-4 family. Let's explore what makes these models so unique and why they're getting attention across the entire AI community. Most state-of-the-art models today rely on hundreds of billions of parameters, often trained with massive compute resources, sometimes for months. But Microsoft decided to focus on something different: careful dataset curation, precision instruction tuning, and designing models to think, not just predict. The Phi-4 reasoning model, with just 14 billion parameters, embodies this philosophy. And the results? Well, let's look at the numbers. Here's the first benchmark. Phi-4 is compared to some of the most powerful models in the world, including OpenAI's O3 Mini, DeepSeek R1, and even Gemini 1.5 models. Take a close look at AIME 25, a benchmark designed to test pure reasoning. Phi-4 Reasoning Plus scores 82.5, beating every other model. Yes, even DeepSeek R1 with 671 billion parameters. In OmniMath, which combines symbolic and numerical problem-solving, Phi-4 is nearly tied with O3 Mini, a model widely praised for its math capabilities. And in GPQA, a test of graduate-level multiple-choice QA, Phi-4 comes close to the top, beating models many times its size. It's not just competitive, it's dominant. And this is just the beginning. Now let's zoom into the smaller model range, where Phi-4 really shines. This chart compares models under 7 billion parameters. The star here is Phi-4 Mini Reasoning. In AIME 24, it clearly outperforms other compact models. In Math 500, it reaches 94.1%, placing it nearly on par with models over 12B parameters. And on the GPQA Diamond benchmark, which tests deep conceptual understanding in multiple-choice settings, Phi-4 Mini leads the pack. But these numbers don't just reflect raw intelligence. They reflect a model designed to reason, not just memorize patterns. That's a crucial distinction. Next, Microsoft tested Phi-4 models across a wide range of tasks, from programming to instruction following, from logic to toxicity filtering. And here's what they found. On Human Evil Plus, Phi-4 matches GPT-4 level code generation for real-world problems. In IFEVL, a benchmark for how well a model follows instructions, it scores over 91%, nearly matching GPT-4o. Toxygen, which tests whether a model can detect and avoid toxic content, shows Phi-4 doing surprisingly well, ahead of some much larger models. And perhaps most stunning, in FlenQA, a benchmark for factual question answering, it scores 97.9%, outperforming almost everything else on the chart. These results paint a clear picture. Phi-4 is not just a clever toy, it's a serious contender in real-world use cases. Now here's where it gets even more interesting. These models are optimized for local inference. That means no API calls, no external servers. You can run them on your laptop or even your smartphone, using technologies like ONNX or GGUF plus llama.cpp. This is a game changer for several reasons. Privacy. Your data stays with you. Speed. No latency from cloud requests. Control. Customize your model, fine-tune it, even modify it for niche tasks. Imagine AI-powered note-takers, search agents, research assistants, or code companions, all running entirely offline. For edge devices, developing countries, or privacy-sensitive industries like healthcare, this opens a world of possibilities. The trend is clear. Smaller, optimized models are no longer just good enough. They're beating the giants at their own game, especially in reasoning. This also hints at where the future of AI is headed. Efficiency-first architecture, smarter data curation, real-world deployability. It's not just about having the biggest model anymore. It's about having the right model, trained the right way, for the right task. So, what do you think? Can small models truly replace giants like GPT-4 in day-to-day tasks? Will local AI become the new standard? Let me know in the comments. I read everyone. And if you found this analysis helpful, please like, subscribe, and share it with someone who's into AI as much as we are. We're just scratching the surface of what Phi-4 can do. So stay tuned. More benchmarks, deep dives, and AI updates are coming your way. Right here with me, Francis.